Okay, so let's get started talking about confidence intervals for one sample proportions. Over and over again, you're going to hear and see the same type of situation, which is a state, plan, do, conclude, which is a simple way to remember everything you need to do when it comes to inference procedures, and confidence intervals fall under the concept of inference procedures. Okay, so state is where you're going to do things like name the procedure, you're going to identify the parameter of interest, okay. In plan, you're going to do things like check your conditions, okay. In do, you can probably guess it, you're going to do the math. You can also under plan or do, you can do this, but you're going to write your correct formulas. And under conclude, you're going to write your concluding sentence. And for those of you who are fans of making up your own sentences, we don't do that here. We use very structured sentence structures. That doesn't make any sense. We use very structured sentences, A, to be consistent and to ensure that you're hitting all of the components that you need to do. Okay. So let's get started and take a careful example. So we are talking about one sample proportions right now. So here are some things that you need to know about one sample proportions. In general, we're going to tell you what the name is. I'm going to tell you what the parameter of interest is, and I'm going to tell you what the conditions are to check and how you check them, and what the general formula would be. Okay. So Miss Glass was an all-star basketball player in high school. To prove that she still has the skills, she took 50 free throws and made 31 of them. Think of these 50 shots as being a random sample of all the free throws she's ever taken. Find a 99% confidence interval for the true proportion of free throws Miss Glass would make. Okay, so here we go. State. This is A1 prop Z interval, because we've asked for a 99% confidence interval on the true proportion of a one sample item. The parameter of interest is the true proportion of free throws Mrs. Glass would make. Next up, we're going to check our conditions. So was it random? Random sample. Okay, so we can say that yes, it was random. Okay, independent. It was not with, well, technically it was with replacement, right? Is 50, though, less than 10% of all her free throws ever? I think you're safe to say yes. You can also say each shot is independent. Okay. And finally, is it normal? Is a normal approximation appropriate to use? Is the large counts condition met? So does 50 times 31 over 50, is that greater than or equal to 10? Well, that's 31, so that's greater than or equal to 10. And then is 50 times 1 minus 31 over 50 greater than or equal to 10? And that's 19, and 19 is greater than or equal to 10. So we've met all of those three criteria. So now we're going to go ahead on the next slide and we're going to actually do the math. Okay. So here we go. We're going to do the math to the best of our ability. And so the point estimator is my p hat plus or minus my critical value times the standard error. And the standard error is the square root of p hat times 1 minus p hat over n. And the only thing that makes this a standard error versus a standard deviation is the fact that it's p hat instead of p's. Okay, so let's move ourselves forward here. So p hat is 31 out of 50, plus or minus. For 99, our critical value is 2.576. You can find the video on critical values afterwards, times the square root of 31 over 50, times 1 minus 31 over 50, and then you can go ahead and complete that calculation. So you get 0.63 plus or minus 0.095, which is equal to 535 to 0.725. You can write it like that, or you can write it as 0.535, 0.725. And last but not least, we conclude we are 99% confident the true proportion of made free throws for Mrs. Glass is captured on the interval from 0.535 to 0.725. See you in the next video. In general, the name of the test is a one sample proportion confidence interval. It gets a nickname of a one prop Z interval, which will also get you full credit on the exam. Okay, so one prop Z interval. The parameter of interest is the true proportion of whatever. So this is in context. Okay, so the true proportion of U.S. children who are sick of school. Whatever, okay, in the context. The conditions, you'll hear me say this 1,000 times over and over again, but the conditions we check most of the time are three conditions, and they are called random, independent, and normal. And you'll also hear me say often run immediately now is another quick way to remember the words for random, independent, and normal. So the random, you're looking to see, was the sample random? Does it state it? Can it be assumed it? Does it say a simple random sample, etc.? Independent, we say that without replacement, the sample size has to be less than or equal to 10% of the population size. We're getting very comfortable with that one. With replacement, or it states independence. Okay, and then normal, because it is a proportion, we say n times p hat, because we don't have the population proportion, has to be greater than or equal to 10, and n times 1 minus p hat has to be greater than or equal to 10 in the large counts condition. Because I do not have the population proportion, I have to substitute a p hat here. Okay, let's go look at an example.